This is a database question. This is a non-calculated question as well. Part A asks for C prime, the approximation for C prime of 3.5 using the data in the table. So we want the smallest interval possible, and we also want 3.5 to be centered in that interval, if possible. And so we're going to pick then the interval from 3 to 4. So we're going to approximate C prime of 3.5 we're going to approximate the slope of a tangent using the slope of a secant. So C of 4, which is 12.8, minus C of 3, which is 11.2, over 4 minus 3. This is free response, so we don't have to simplify. Part A also asks us to indicate the units. So the units on top are the units for C, which is ounces, and the units on bottom are the units of time, which is minutes. Moving on to part B. Part B says, is there a time for t between 2 and 4 at which C prime of t equals 2? So because the table gives C values, and they're asking about a C prime value, then that's the indicator that this is a mean value theorem type problem. What they tell us is that C is differentiable. C is differentiable. So C is continuous on the interval from 2 to 4 with C of 4 minus C of 2 over 4 minus 2 equal to 2. So there's our slope of our secant equal to 2 for that interval. So there is a t in 2 to 4 with C prime of t equal to 2. Because the slope of the secant for that interval is 2, then there must be a t inside that interval where the slope of the tangent equals 2, and by MVT. And what we're doing here is conditions, analysis, conclusion, theorem. Our conditions, C is differentiable and continuous on this interval. Our analysis, showing that the slope of the secant is equal to 2. Our conclusion, which is basically what they asked us in the question, that there's a t between 2 and 4 where C prime of t equals 2. And then our theorem, which is by MVT. Part C says, use a midpoint sum with 3 subintervals of equal length to approximate 1/6 the integral from 0 to 6 for C of t. So then 1/6 the integral from 0 to 6 for C of t dt is approximately, that midpoint Riemann sum is going to approximate the value of the integral. And this is 3 subintervals, so base times height, base times height, base times height, 3 midpoint rectangles. Often what students will forget here is that constant multiplier on the outside of the integral. This is 3 subintervals from 0 to 6, so from 0 to 2, from 2 to 4, from 4 to 6, which means every subinterval has a length of 2, and then using the midpoints of each of those subintervals to determine the height. So 5.3 is the first y value at the midpoint, 11.2, and 13.8. This is free response, so then no need to simplify. And then they also asked us to explain the meaning of that integral. When I see the integral divided by the interval, then that tells me average value. So the average amount of coffee there's our noun in ounces. There's our units from t equals 0 to t equals 6 minutes. There's our time. And then part B, needs a different color. They give us a new function. They tell us that, not a new function, but they tell us that the amount of coffee in the cup can be modeled by this function. And they say find the rate at which the coffee is changing when t equals 5. So if I want the rate, then I'm going to differentiate. B prime of t is going to be the derivative of that constant 16 is 0. Negative 16 is a constant multiple. E to the power of, the derivative of e to the power is e to the power of, leaving the exponent alone, times the derivative of the exponent, which is negative 0.4. And we want the rate of change of the temperature of the coffee, or the amount of the coffee, at t equals 5. So then plugging in 5. This is free response, so there's no need to simplify. A few years ago when we gave this problem on a mock exam, so many students did the derivative correctly, plugged in 5 correctly, simplified incorrectly, and lost their points. So no need to simplify for the free response problems. The first point comes from the approximation for C prime of 3.5, the setup and the answer, and this difference quotient that's shown is both the setup and the answer. 1 point came from the units, 1 point came from finding the slope of the secant from 2 to 4, another point came for the correct mean value theorem justification, 1 point came from the midpoint Riemann sum, 1 point came for the approximation of the average amount of coffee, which means the students didn't forget to leave off the 1/6. 1 point for the explanation or the interpretation of that average amount integral. 1 point for finding b prime of t correctly. 1 point for plugging in 5.